Hello everyone, my name is Randolph Jeffrey Kwao, an optometrist and a PhD student at University of Houston College of Optometry. Currently, I am interested in any condition that impedes binocular vision, and an example is amblyopia or lazy eye. What is amblyopia? It's a form of visual disability that emerges during infancy when input to the visual cortex from the two eyes are poorly balanced. In layman's terms, you visit your eye doctor because of poor vision. You decide to read the letter chart. One eye is able to read completely, and one eye is unable to read the letter chart. So what your eye doctor would do is try to give you glasses to improve vision in the bad eye. Now, no matter the prescription the eye doctor gives to you, there's no improvement in vision of the bad eye, and that's what we call amblyopia. And so with a conventional treatment for amblyopia, we put a patch on the good eye and we force only signals from the bad eye gets to the brain, and that results in brain rewiring and helps in improvement in vision of the amblyopic eye. Now with this treatment, it has its own limitation. One is that the treatment duration is quite long, can take between 6 to 12 months. Another limitation is that there's also poor compliance, because especially children, when they have this patch on their good eye, they do face stigma from their friends, and sometimes they do remove the patch. And so it's quite challenging. Another limitation is also that this treatment is quite effective within what the period we call the critical period, which is between from 1 to 10 years. And after 10 years, this treatment is quite challenging. Now, our lab is trying to find an alternative treatment protocol to overcome these challenges associated with the conventional treatment. And what we are currently using is a pharmacological drug called tetrodotoxin, TTS. And with this drug, with the right amount, we inject it into the good eye. We temporarily shut down the good eye for 5 to 7 days. And then it improves vision. There's an improvement in vision of the amblyopic eye. Now, this kind of treatment that we are doing is in non-human primate models, and then it is important that we try them on non-human primate models because they are similar to humans. And so understanding the effectiveness and the safety of this drug within the non-human primate will help us in the future to translate to humans for further studies. And so federal funding is quite important for this kind of treatment, because even to purchase a non-human primate is quite expensive. And so when funding to this project is affected, it's also going to affect the whole studies, which is going to also impede our understanding of the new drug to treat amblyopia. Now, participating in this emerging science program, vision science program, will help me to talk to policymakers about the importance of my work, because currently the prevalence of amblyopia is estimated to get to 221.9 million by 2040. So finding a solution or finding an alternative method that can treat amblyopia within the shortest possible time and can overcome these challenges associated with the conventional treatment will be ideal. Thank you.